All right, in this video, I'm going to show you how to build this 10 horsepower rotary phase converter. I'm going to include a parts list in the description, and I'm going to also give you a wiring diagram that shows you how everything gets wired up. I needed this for a Hobart mixer grinder along with some other things that I have, equipment that I have here in the shop, and I couldn't find it anywhere online, so every video I found would either be someone building it but not saying what's going on, not showing the components that they're using, not giving any kind of wiring diagram, or if I found something online, it would give me some advanced formula on how to figure out what kind of capacitors I need, but would never give me the information I actually needed. So I decided to get all the information, build one, and put it out there for anybody else who is in the same situation that I was. So follow along as I build this phase converter. Okay, so I think I've got it figured out what I need. So I'm trying to build a 10 horsepower phase converter so that I can run a large Hobart mixer grinder. Now this phase converter can be used for other things. I also, up on the shelf, I have a 3-phase commercial table saw and a few other 3-phase items that I've never been able to run properly. So I decided to build this 10 horsepower phase converter with a push button start. I didn't want to do the pony motor to get it started. At a certain point, I'll make sure I put in the wiring diagram drawn up properly. This is just a quick sketch of what I'm doing, but I will draw it all up real nice for everyone to see, and so I will make sure to put it on the screen where you've got a chance to pause it and see the actual wiring schematic. And then I will also put a parts list, what you need to do this. And then you can either buy it on eBay, Amazon, whatever your platform of choice is, or in my case, most of this stuff, all except for the capacitors, I am pretty sure I have it in my bins of things that I've saved. I am still far from being done organizing. However, I did get this shelving at a Big Lots that was going out of business, and it works great to organize my stuff. And this is my electrical aisle. Let's see if we can find what we need. So my bins aren't perfectly organized, but I do have, there's control wiring in there, and this also is control. So let's get those 2 bins. This one, let's see, and it's this one. Let's see here. That is a timer if we want a timer. I may use a timer. I'm going to see how things go. What do we got here? There's a stop switch. And the coil on this thing is 220 volt. We can make that work. I'm actually going to need 2 of those. It's a 120 volt coil. I can make that work, and it's only got two pull, but that's okay. I can make that work. And as you can tell, it's full of all sorts of junk. You know what? This terminal strip might be overkill, but we can make that work. 240 volt up input, 32 volts. .4 volt coils. Wow, I've got a lot of 24 volt coils. the rheostat, gas valves, thermostats. No. Hey, more switches. Hey, we can make that start switch work. And there's another stop switch on there if I want it. .240-volt coil on that thing. That'll work. Then I don't have to worry about some of my controls being 120-volt coil and some of it being 240. Let's see here. No, those are momentaries that aren't going to work for me. Limit switches, air solenoids, water solenoids. I got all sorts of crap. And it basically comes from me just, you know, saving stuff. When I tear something apart, I save it and use it in situations like that. Some of this stuff I've had for many years. Some of it's been put in here in the last year, maybe. All right. Well, let's take these parts over, get off what we need, and go from there. That's really good. Hey. Oh, no, wait. Yeah, I got it. I don't think we're. I don't think we're. Yeah, I'm right now. All right. Okay. Okay. So. That check. That check. That check. That check. Okay. Now I will go and buy a few things that I still need that I'm short, and I'll be back again. Okay. Got my plug, capacitors, and that one's gonna go with that. So they didn't have exactly what I wanted, but they had what would work. So these are multi-tap capacitors, and I needed 150 microfarad. So they've got a 50 and a 5. They're used for HVAC type stuff. So I can use the 50 off of each one of these and get 150 microfarad for the capacitors between L1 and L3. Then I've got 15 microfarad to go between L1 and L2. And then I wanted 110 microfarad between L2 and L3. The closest I could get is this has 85 and 5. So, or sorry, this has 80 and 5, which is a total of 85, and here's 20. So that'll get me 105. I think that's close enough that we're going to be okay. And that will go between 2 and 3. Then for the start, also going between L1 and L3. For the start capacitors, I have 800 microfarad is where I wanted to be, and this is 2 of them that are 400 to 480. So that'll put me right where I need to be. So with that, what I can do is I can set everything up with the values I have and then check my voltages between each leg and see if my voltages are balanced. If they're not balanced, I can adjust with different capacitance values on the different legs or between the different legs. So next thing is, let's get the motor up here. This is what we're going to need to get in that case. And so let's get the motor up here and see what we can do. My thought was attaching a box on here that can hold everything I need to hold here. And I think I'm going to make my own box because I've got sheet metal stuff here. Actually, what I'm going to try to use is a piece of, I'll show you. So, this is a skirt off of the shelving that I have here that with my application, I'm not using this skirt. So I think I can cut this in half, flip it over, and make a box out of this. So I think that's going to be the next step. Okay, so if you look right here, what I did is I brought everything through here. This is the bolts that hold it to the motor, so I think we're good there. I'm not confident in that being the only thing that holds it. I think so. I'm thinking if I weld this box right to the base of the motor as well, I don't really care if it's welded. I don't really care if it's welded on here because, I mean, I cut the shaft off of this thing, so this motor will never be good for anything else. So I think we may as well just weld it on here. And if it goes bad for this, it's going to be bad anyways. So, and if we ever do need to take it off, I can always cut the weld if I need to. So let's go ahead and do that. Okay, I think next I want to paint this whole thing. So I'm going to clean it up and get a coat of paint on it just to make it look better, seal it. So give me a second, we'll get some paint on here. Okay, I guess we're going to be black because that's what I've got left over from painting the axle for the Steiner 230. So, I found some ink blue paint, and has to have multiple coats anyway, so I think I'm going to switch to ink blue. All right, it's been about 15 minutes. I think we can get another coat. This is tacked up just a little bit. So when I was at the electrical supply place, they had these rubber mounts for $1 a piece. And I think what I'll do is I'll mount these on the bottom to give it a little bit of insulation so I don't have vibration sounds going through my whole shop. And in case you haven't noticed, I'm very impatient. This paint is still very wet, but I'm gonna go ahead and put these on just because I'm impatient. Yeah, see? Very wet paint. A little touch up where I nicked it. Now, since we do have the rubber feet on it, I can go ahead and put this on the workbench. 18 by 11 3/4. Okay, so since I already have a hole here, and I need to use a hole saw, what I'm going to do is take a piece of wood, cut a hole like this in it, clamp it on here, and use that as a guide to guide me since my center pilot hole won't guide me. Now what I can do is line that up just like that, and I'll clamp it. Now this piece of wood will keep me centered in. Now I need to just make the 2 holes for the screws that hold that on. Okay. Okay, we're back. The paint is dry. We are ready to put everything in here. And so full disclosure, I had built this before and I tore it apart to redo it, to make it more professional, to make it look better. And therefore, because of that, I do have all my wires. These are all the wires I need to put this together, as long as I put the right ones in the right place. So, without further ado, let's get to it. Because I've done this before, I do know that I need holes here for my start and my stop switch and my cord to go into it. I do think, however, I may want to bring my cord in back here, just so that if I've got it facing out, my cord comes out of here, my buttons are over here, and my plug is here. I don't know that I want the cord over here. I do have capacitors. My capacitors will be sitting here. These will be over here. Let's see, I had these 2 will go here. These will go here. And this one here. So, boy, this is here. This contactor goes here. You'll take this contactor and put it here. Okay, I can bring my cord in right here. That gives me enough room to bring the cord in right here. Yeah, that's what we're gonna have to do. Right there, and we'll just have to strip it long enough to where the wires can reach over to where we want to go. Okay, so I'm going to make a mark here, right here. That's how far my contactors come, because once I have everything drilled that I need to drill, I'm going to put a piece of adhesive down here to hold my capacitors in place. So now with that, let's go ahead and drill a hole right here for that cord to come through. On the original build, I had brought the cord in here, and I'm not sure that I like that, but I also don't know if I like the idea of this being, yeah, it'll be fine. It'll be fine. Okay, got those in. Let's get this thing mounted in place. This is going to be our terminal strip where we'll take all the wires from the motor to the terminal strips, and from here we can connect on. That way we don't have a bunch of wire nuts in here. It can be done with wire nuts. I just think it makes a nice clean setup when you have something like this in it instead. And I want to get everything mounted so that I can get all these crumbs out of here from drilling and even the self-tapper screws. Put a little bit of shavings down there, and I don't want that. I want to get that all out before I put my adhesive down. Now we're ready to blow this out, get some adhesive down there, and mount our capacitors in there. So this is 3M adhesive. I have sheets of this for projects that I do with my laser engraving. Getting old sucks. Glasses on, glasses off. I'm actually looking into LASIK eye surgery, which it's actually called PRK. It's not quite the same as LASIK, or it's a version of LASIK maybe. If any of you out there have had that or have experience with it, let me know what your experience was. I'm really curious. I haven't scheduled the actual date, but I have been approved. Oh, and by the way, you see me touching these. I made sure I used a screwdriver because they have been hooked up before and shorted them out. If you don't and you happen to touch these, you will get shocked. Just a fair warning. When I was at the Career Center, we would take these and hook a wire onto each one of these, make so it's long and stripped, and wrap them around where they're not touching each other. Then we would charge them and strategically hold them and toss them to someone. And when they'd grab it, they'd get zapped. These starter capacitors are running through this contactor. And what that does is it makes so that we are only engaging this contactor while we're pushing the start button. That's why we have two outputs on the start button. That way they're isolated, because this one is going to be continuously engaged while this thing is running with the interlock that's on the side of this. If we don't have a separate start to isolate it after this is engaged, the latch that we're using this normally open contact for to latch this one will also backfeed through the start and also keep this one latched. Now, one thing I recommend is always go back through, make sure all your screws are good and tight. You can get them with a Phillips to get them started, but then I like to always finish tighten them down with a flat screwdriver because you can just get better torque on it. And a loose connection is a hot connection. Keep that in mind. If your connection is not tight and it starts arcing, that is when you get a fire. This is better than being on my knees. Got a chair. It's my old office chair. I think I'm missing a wire. We need to drink some coffee. We need coffee. Coffee is good. Yeah, this, it does say Yeti. I know my mug says Yeti, but if you look real close, it actually says this is not a real Yeti. I engraved it and figured, why not put something funny on it? This was originally a blue mug that I messed up for a customer. So I lasered the whole thing with my fiber laser. And that's what gave it this texture, because I did an engraving that actually dug into the metal. Then I did around the bottom and the top, I annealed it, all except for where it says Harley Davidson. And then I did an old Harley Davidson style logo there and a Harley Davidson logo there. It says Harley Davidson all around the top. I engraved Harley Davidson there. And it's actually engraved on the inside as well with Harley Davidson. And yeah, what you see in there, that's billup. I don't wash my coffee mug. That ruins the taste. It's seasoned. I rinse it every day, but I do not wash it. I know, sounds gross, but it makes better coffee. And the bottom of the mug also is engraved, by the way. But anyways, yeah, don't wash your coffee mug. It makes your coffee better. It's probably the mold and, you know, all that stuff that's adjusting the flavor, but I like it. Anyways, okay, back to what we were doing. I have the wiring diagram for the motor on my phone. Let's see here. Somewhere. How long ago was it? There it is. Looky there. Low voltage and high voltage. So low voltage would be your 240 volt. High voltage would be your 480. We're not running 480. I do already have 6, 5, and 4 tied together here because I didn't have to undo that. But I'm not 100% sure, but I think these numbers and the wiring on the way the leads coming out of a 3-phase motor are numbered, I believe is an industry standard. Not 100% sure on that, but I believe so. I'm using a drill, but I am only going until I can feel resistance. I am not letting it really torque it down because I want to have more control. Okay, now I should also have a black wire like that, and for some reason I have the black jumper, but I can't find the black wire that is a little bit longer and has my spade connector on one side and bare wire on the other. So let me do a little searching. Okay, I found it. It was on the floor. Okay, now let's get some power to this and test everything. I have a 50 amp welder plug on this end. I will grab my cord for my welder and plug it in. Okay, we are ready. We are ready to test. Let me just make sure we have the proper voltage coming into our feed. We've got 241 volts, and let's hit start. Okay. Our stop works great, start works great, and if you noticed, I didn't have to hold this long. If I don't hold it long enough, I'll show you what happens. Did you hear that buzz when I didn't hold it long enough? That is the start capacitors not being engaged long enough, because the start capacitors are only engaged while I'm pressing this start button. That's why we have the second contactor for those start capacitors. That prevents us from having to have a pony motor to get this going. The other thing is we had to isolate it so that when we press the start button, it engages this and this. However, this one is latching, so it has to be a separate feed from the start button over to this one so that it can't backfeed through the latch we have for this one. If I hold it too long, it'll do the same thing where it will start to do the same humming noise. I'll do that when I start it this time. Holding the button extra long. Hear that extra buzz? So it's pretty simple to just hold it for the right amount of time. You'll be able to gauge it pretty quick. Let that wind down a little bit. I'll show you how easy it is. It's a very simple, just hold it for a few seconds, or 1 second. I mean, I knew from experience from having had this together before that in order to not push it long enough, you have to be as quick as possible to not have it long enough. And so it's simply just reaching up and pushing the button and it goes. That's simple. Okay, for our voltage. This is L1 and L2, L1 and L3, L2 and L3. I'm sure you noticed my voltage was extra high between 1 and 3 and between 2 and 3. That is much higher than you typically want it. However, because we were up at 280 and 260, however, once I get a load on there, I did discover that it pulls it down to the voltage we need to be at. If I reduce the capacitance between legs 1 and 3 and between legs 2 and 3, I get the correct voltage when it's freewheeling like this. However, once I get a load on it, I go down below 200. So what I've discovered is, with this the way it is, it runs at the correct voltage with any kind of a load on it. I've tried my 3-phase table saw that I have. I've tried the meat grinder that we used. And with each one of them, when I get the load on the phase converter, the voltage drops down right to where it's supposed to be. And so I feel it's more important to have the absolute correct voltage when it's running rather than when it's not running. I also did make sure that all of the equipment I run on this is using L1 and L2 for the control wiring. There's not too much equipment, if any equipment out there, that runs the controls off of 3-phase. So since you're running it on single phase, 1 and 2 is your original voltage. And so if you make sure that L1 and L2 are your control voltage or your control wiring, then you won't have any issues with burning anything up in your controls by having too much voltage. So it's just that third leg, and your machine, as long as the control wiring is wired to run off of L1 and L2, your machine will not ever see that extra high voltage that's on L3. So, or in this case, it's the output, so it would be T3. All right, I'm gonna go ahead and go in and I'm gonna try to engrave this strip here so that I can have everything labeled correctly on my strip, and I can just at a glance see that I've got everything at the right spot. And once we have that, we'll get this front cover on. Okay, we've got our strip all engraved, ready to go in here. Oh, and if I did forget to mention, at this point, our capacitors have been recharged, and it would be a very electrifying experience to touch them at this point. So, everything's labeled what it is, and next is our front cover. I've got the receptacle mounted in here. It's got 2 screws. Sometimes I get frustrated with myself because I'm a pack rat. However, when I'm doing a project like this, I'm happy that I saved all this stuff. Okay, let's see. We want enough wire here to be able to lower this panel down in front of it. So about that much. So, the front cover. That way, we've got the 10 horsepower, the output, all that stuff. Wanted to make it pretty, and I like my logo. And if you haven't figured it out, 0.5 is half. That's a donkey. So it's 0.5 garage, but it does have more meaning than just the 0.5 garage. Anyways, we do things 0.5 donkeyed around here. And, but this was an upgrade from the 0.5 donkey style. All right, there you have it, a 10 horsepower rotary phase converter built from scratch. What you see on your screen right now is the wiring diagram of how I've got everything wired up inside here. The red lines are all your control wiring, and the black lines is all the rest of the wiring. I've had lots of training in control wiring and electrical wiring in general. I've worked as an electrician for numerous years. However, I am not a licensed electrician, so consider that the disclaimer, I guess. All right, if I missed anything or if you have any questions, don't hesitate to put it in the comments down below. I'll try to answer all those questions to the best of my ability. I will also put a parts list in the description. That parts list will have switches and the internal components. I won't put this in the receptacle because you may not use the same one I did. I will not have a box in there, and I will not have the cord or the motor in there. This will be just the internal components that are listed on the wiring diagram. If you enjoyed this video, please like and subscribe. It helps my channel grow. It helps YouTube know that there's people out there that want to see this content, and it helps keep me encouraged to continue to do content like this. There should be a link here and a link here that take you to other videos that I've done, other projects I'm working on. And with that, I guess, thank you for watching. We'll see you next time.